you want to install PV on farmland in operation or on complex landscapes with a lean solution. How this can be possible, we learn now. Welcome to the booth of Solargik. On my side, I welcome Horowitz. He is CCO of Solargik. Mr. Horowitz, you constructed a very new agri-PV system. There are already agri-PV systems on the market. What is special on your solution?
Okay, so what we're trying to solve for are the two main challenges that we see across all European markets in PV. First of all, we need to be able to elevate the solutions to height, right, to allow the farmers and the agriculture to continue to thrive underneath. The second is, how do we balance between the crops and the energy generation, right? And I think what unifies this is the fact that across Europe, whether you're in France, or you're in Germany, or you're in Italy, you have different regulations around the height, around the ground coverage, and what we really see is the need for a versatile solution that can fit across these markets. Most of the trackers on the markets are taking their standard ground mount, they're trying to pull it up a little bit at height and hoping that it will work. We started from the ground up with a different approach. We said, how do we make this tracker work on all the challenging terrains to allow all the agricultural activities to continue? And how do we control and monitor it in a way that allows us to spread this across the market? So as opposed to just taking our standard, we built a special product that can go up to 5 meters in the air, right? That's very, very different, and we're controlling it with a very different motor. You see our motor here is much smaller than any other standard motor you'll see on a tracker. That allows us to use a lot less steel, which makes the installation for the farmer a lot easier, a lot less intrusive, right? And it allows us to design the trackers to adapt and fit into the agricultural settings, as opposed to forcing the agricultural to fit into the solar world. And that makes it easier for the farmers to deploy on their land. And then it makes it easier for the investors and the EPCs to build it in a way that matches and fits into the existing agricultural setting.
And this is because your tracker is very lean, very compact and modular. And what is the advantage? How do you build these trackers?
Okay, so we've built it in a way that can be as flexible and versatile as possible. So for example, we can design the pylons, the legs of the tracker, in a way that can be built or connected to the ground, either most common way by ramming. We can use it with ground screws. We can connect it in very different ways to whatever fits the local agriculture and the local terrain. Right, and that makes it easier to deploy in more scenarios and in more settings.
Yeah, and I saw you build it, the tracker itself outside of the area, and
yes. So instead of needing to build everything on site or on top of the crops, because sometimes if the farmer already has a field or a vineyard, we're not going to just flatten it. So we make it so that you can actually drive the piles first, then you can build the PV tables on the ground, and then with a crane lift them and connect them very simply just with the bearing up top. So it makes the installation process much smoother, right? Less time consuming, and without harming any of the agriculture that's already on site.
And you can build your trackers also on difficult terrains. How this can be possible?
Yeah, this is probably where we should go to the other tracker to show the difficult terrains.
Okay.
So what we see here is actually, even though they're sharing a leg, this is actually two different trackers. Most trackers, the problem or the challenge on slopes is, how do you transfer power? How do you have one motor that's moving the whole row? Other trackers have tried to control that with joints, which are complicated, hard to install, and costly. And they're doing that because they're still focused on having one motor to move the whole row. Instead, we're solving that challenge in a very different way. We're using more motors that are now cost efficient, very reliable, and easy to obtain. And by doing that, we don't actually have to connect the torque tube. That also gives us an amazing advantage in terms of control. What does that mean? This panel over here, even though they're sharing a pylon, are actually two different tables. So this tracker and this tracker can have their own separate control panels and be on different angles. And that way, even on slopes where we see this type of challenge, they can be pointed in the right direction, which they wouldn't be able to if they shared a joint and one long row.
So it's easier to control these trackers separately?
Yes. It's the only tracker that can control that small of a block of 8 to 24 panels. Every other tracker is at least 24 panels or more. Here we're using smaller building blocks that have better control, and we're obviously wrapping that together with our own unique software solutions as well.
How do you control the whole tracker system basically?
So we have, each tracker has its own computer, right? Its own connection to the local control center, and our central control system is monitoring the whole plant. It's giving each tracker its own angle and own inclination based on wind speed, based on location, based on the topography, based on the tracker next to it, based on time of day. So it's incorporating all of the data together and then giving each tracker its own command in order to go into the right angle at that time.
Yeah, and you have also a monitoring software for this tracker?
Of course. This is our monitoring platform. And what you can see here is our ability to control and monitor the entire site. On the one hand, we can see how much we're generating in real time. And more importantly, we can also understand whether or not we're taking advantage of the full potential of the site, right? If we could be producing 85 and we're producing 83, that's actually not that bad, 98% in terms of the overall production. And we're uniquely positioned to do this because we're incorporating multiple different sensors into the platform, right? We can look at real time, we can look at historical numbers, we can see what was going on in terms of the wind, and we can also see production relative to irradiance, all at a very granular level. Now, again, as a tracker manufacturer, you would expect us to show you this piece on the right here, what's happening with the trackers, how many of them are working. What's surprising is that we're also able to look at things like inverter performance and take into account the entire site and its situation. And we can go much deeper than that. If we are not producing, or the plant is not producing what's expected, we want to know why. We can actually go into our performance loss analysis. What we're doing here is we're taking siloed data pieces of information, looking at them holistically and figuring out, wait a second, it's now 9 o'clock and I have this dip. What happened? Let's go check. Let's click on what happened to my inverter. Well, my inverter tripped a voltage grid voltage, and now I can understand why during that time I was actually not generating the amount of energy that I should have been generating.
Thank you, Mr. Horowitz,
Thank you,
for this
Thank you.
amazing system, for this amazing solution, for the informations. And if you want to know more about the solution of Solargik, please use the website.